Hi students, problem number 9, subdivision A. Two insulated charged copper spheres A and B have their centers separated by distance of 50 centimeter. What is the mutual force of electrostatic repulsion if the charge on each sphere is 6.5 into 10 power minus 7 coulomb? Radii of the spheres are neglected. Radii of the spheres are neglected as compared to the distance of separation. So this is a subdivision A. First we will solve this. So now you can see Q1 and Q2 are the charges which are distributed on two copper spheres which are insulated. So they are separated by distance D equal to 50 centimeter. So Q1 is equal to Q2 and that is equal to 6.5 into 10 to the power of minus 7 coulomb, and the distance of separation is 50 centimeter. So that is equal to 0.5 meter. So we have to directly apply the Coulomb's inverse square law and find the force. So F is now equal to 1 by 4 pi epsilon naught into Q1 into Q2 divided by the distance square. So the value of 1 by 4 pi epsilon naught is 9 into 10 to the power of 9 into now 6.5 into 10 power minus 7 whole square. Both the charges are same. So I can write 6.5 into 10 to the power of minus 7 the whole square, and this is divided by 0.5 whole square, 0.5 the whole square. So if you calculate the value, if you calculate using a calculator means it is found that the force is equal to 1.52 into 10 to the power of minus 2 Newton. So you have to expand this using a calculator and divide this by 0.25. So what is the value you will get is 1.52 into 10 power minus 2 Newton. That is the repulsive force between the two copper spheres A and B. Okay, now coming to subdivision B. What is the force of repulsion if each sphere is charged double? Double means comparing to its previous charge, Q1 is double means it becomes 2Q1 and this is 2Q2. Okay, double the above amount and the distance between them is halved. So for subdivision B, now I will take Q1 dash. The charge in the first sphere is Q1 dash. So this is equal to 2 times Q1. Okay, and Q2 dash. Q2 dash is 2 times the charge Q2. That's the meaning, because the charge double the above amount Q1 and Q2. Then the distance between them is halved. So D dash is equal to D by 2. So I am going to substitute this condition in the above equation. Therefore, the new force of repulsion I will call it as F dash. F dash. So this is equal to 9 into 10 power 9 constant will be the same in this case also. Is it not? Only the charges are doubled and the distance is halved. So this is 2 into Q1 into 2 into Q2 and this is divided by D by 2 the whole square. So this is now equal to, this is 2 into 2 is 4, is it not? 4. So this is 4 into, remaining factors in the numerator are 9 into 10 to the power of 9 into Q1 into Q2 is 6.5 into, okay, 6.5 into 10 power minus 7 the whole square divided by, now D square by 4, it is D square by 4, is it not? So this is 0.5 whole square divided by 4. Now this 4 in the denominator is appearing in the numerator, so it will become 4 into 4, is it not? Therefore now 4's f is equal to 4 into 4 into the remaining factors are same as that of the first case. So this is in bracket I will write. So this is into 9 into 10 power 9 into 6.5 into 10 power minus 7 the whole square. Okay, divided by this is 0.5 the whole square. So this is a 0.5 the whole square. Okay, 4 into 4 is what? 16. So this is 16 into, we have already calculated this value in the first case. So that value 1.52 into 10 power minus 2 can be substituted. So 16 into 1.52 into 10 power minus 2. So if you multiply 16 with 1.52, this will be equal to 24.32 into 10 power minus 2. So this is equal to 0.2432 Newton. Okay, or F is nearly equal to 0.24 Newton. So this is the new force of repulsion after the charges are doubled and the distance is halved. Anyhow, this type of questions you can expect in the NEET and JEE entrance. So very easy and directly substitution type of problem. So this is based on Coulomb's inverse square law. I hope you must have understood well. Fine.